Okay, so integration techniques and improper integrals. You already know the integration techniques. Now we'll go to improper integrals. Evaluate an improper integral that has an infinite limit and that has an infinite discontinuity. So there are basically two types. So how do we know if it's an improper integral? If it gives us, for example, in this case, if one of the limits is infinity, that's already improper. So how do we deal with improper integrals? What we do here is we replace the limit. What makes it improper is the infinity. So you replace that by a letter B or a letter. Typically for me, if I write that A is the bottom, B is the top. So since it's found on top, I'll replace that with letter B and then evaluate it. Pero when you evaluate it, and then you'll end up with this as an answer, the one in red, I will still write the term limit. Bakit? Kasi I have not substituted yet the infinity. Once you substitute it, tapos na. You can evaluate it na. So, sa type 1, look at this. Improper integrals with infinite limits of integration. Sa type 1, the infinity might appear on top, the infinity might appear at the bottom, or it might appear on both ends. So if it's on top, what we do here is we replace the top with letter B and then B approaching infinity and then evaluate that. Here, if it's at the bottom, you replace it by A. Now, if it's continuous on this interval, pero negative infinity to positive infinity, what we do here, guys, is we split it into two. And then this one is your number two. Number two. This one is your number one. Similar to number one, no, di ba? So, evaluate them using number one and number two. So, for example, guys, this one, alam natin you can't have infinity. So, what we do here is, b approaching infinity, I need to write the limit term. So, after evaluating, ln of x siya, we know that, from 1 to b. But then what is 1 to b? What's b? B approaches infinity. So you need to write the term limit as b approaches infinity. And then let's plug in. ln of b or ln of infinity is infinity minus 0 because ln of 1 is 0. The thing is, if it's infinity, you say it's divergent because it does not converge to a single value. If it converges, it is called convergent. Let's go to type number 2. Type number 2, look at the numbers. The limits are numbers, not infinity. However, there might be discontinuity because of some of the limits. For example, this one. Guys, what makes this discontinuous? Diba 0 up to 1? What makes it discontinuous? Diba, you can never integrate this when x is 0 because 0 cannot be in the denominator. That's why what we do here is we replace the 0 by letter B. So when we rewrite this can be rewritten as limit as B. It's at the bottom. So let's write it as A. Pero ginawa niya kasi B eh. It can be any letter, don't worry. So in this case, ginamit niya B. 0 from the right, B up to 1, dx cube root of x. So what does B approaches 0 from the right? It's here. Look at the bottom. It means 0 is not included, but anything x to the immediate right or a bit greater than 0 is included already. So ito lang siya. Madali lang siya. So again, as a summary, there are two types. Two types is if we have infinite limits. That's a first. The second would be if we have discontinuity. Look at this. A is included, but B is not. Or A is not included, but B is included. Or sometimes A and B are both included, but in the middle, it's not included. We split them. Para rin siyang case 3. Ay, yung case. Number 3 of type 1. So look at this. Ito I already solved it for you. 0 is okay, but then you have infinity on top. Therefore, let's replace infinity with letter B. And then evaluate that as B approaches infinity. And then you can plug in. Here, you have a finite answer. No problem with that. This one, I won't dwell so much because this one is basic integration techniques. Again, this is type number 1 because you see infinity. So with that, since it's the lower limit, I replace that with letter A. And then you'll notice here, guys, that you'll get infinite as an answer. So that means it is divergent. It does not converge to giving you an area. Next, paano to? Parehong infinity. E di what I do, I'd split them into two. Split them here at 0. So negative infinity to 0, 0 to infinity. So since it's the lower limit, it becomes A. It's the upper limit that I need to replace. Yung upper infinity, it becomes B. You'll notice that both of them are arctangents. I did no problem with that. And then, so again, as I said, so long as you still haven't plugged in A and B, I need to see the limit term there. And then plug them in, you'll get an area. Now let's go to case number, ano ba to? Okay. So ito, absolute value, but with infinite. So this is case 1 still. Pero saan ba siya magka-cut? Kasi di ba sabihin nyo, Sir, di ba pagka gantong form, A up to 10 lang siya, where limit of A approaches negative infinity. If it's not an absolute value, ganun siya. Like, look at this. Ito, mga ganun lang. Uh, basic lang siya na isang term. However, since this one, guys, contains an absolute value, what's the critical value of the absolute value here? Isn't it ang critical value niya is x equals 5? So that means you have to cut that in a way na dalawa yung terms mo. One term is that when x is less than 5, you'll use the negative of z minus 5. If it's greater than or equal to 5, you'll use the positive. So ito, mahahati siya into 2. And then that's when you apply the type 1 in here. Pero ito lang yung may type 1. Ito okay lang. You can evaluate this immediately. However, you will notice that here, you still got infinite. So pag may infinite siya, divergent pa rin siya. Ito, similar. I won't answer this anymore. By parts lang siya. Ito, let's go to type 2. Sa L'Hopital's, hindi, okay lang. L'Hopital's rule lang yan. Ito, type 2 tayo. Look, in here, wala nang infinity. But, you cannot evaluate this when x is 0. This is called type 2. Since type 2 siya, I'll replace the bottom with A, and then that approaches 0 from the right. And then, when you evaluate this, 6 lang yung answer. So, again, ganito yung itsura niya when you draw it. Yung limits the limits like this. Now, in this case, 1 minus sign, alam natin bawal mag-0 yung bottom. Kailan ba mag-0 yung bottom? When Sine theta equals 1. When is sine theta equal to 1? At pi over 2. Eh, di ba yung pi over 2 is in the limit there? So you will need to replace that by b. So from 0 to pi over 2, but b is not included. Ito. Kaya, ganun siya. And then, yeah. So here, ganun din. Ito, pinagsama yung case 1. Ayun o, case 1 is infinity. And case 2. So you'd be able to solve using this. Pero this one is for your asynchronous session. I already have a recording for this and I already have the annotated slides. I'll be providing you with the annotated slides. So these are some examples that you can study for. Tapos ito yung problem set ha. Please don't forget to answer the problem set.